Hello, welcome to Maths with EJD. This is the second video on trigonometry, and here we'll be talking about foundations of trigonometry. Foundations of trigonometry. And in the last video, I talked about trigonometry being three angles measurement, and then I went ahead to talk about triangles and their classifications based on the sides they have and the angles they have. So today we are going to lay some foundations that we'll have to build on to talk about other aspects of trigonometry. And talking about this foundation, right, I'll be mentioning, I'll be talking about secular measures. I'll just touch on that briefly, as we are going to see. Then um, I'll talk about Pythagoras theorem. Pythagoras theorem, that's going to be very useful for us. Pythagoras theorem. Pythagoras theorem. This is some high school level idea. And then we'll talk about trigonometric ratios. So these are some three foundations we'll be talking about in this video. Trigonometric ratios. Okay, so let's move ahead as we talk about secular measures. So here I'm just going to establish the fact that angles are measured. There are different ways of measuring angles. So talking about circular measures, right? In the first video, I told you about angles from 0 to 360 degrees, and we went ahead to take all this 0 degree angle. Between 0 and 90, we have acute. At 90, we have right angle. Between 90 and 180, we have obtuse angle. And at 180, we have straight angle. Between 180 and 360, we have reflex. And at 360, we have a revolution, right? So talking about circular measures, I'm just going to talk about the fact that circles are measured, circles are measured based using different types of measurement, like degrees. That So we have angles measured in degrees. They're measured in degrees. Angles are also measured in radians and even gradient, and even gradient, and even gradient. But you know what? I'm going to focus on the first two, right? So basically talking about degrees and radians, let's look at comparison between the two of them. So in when you have 360 degrees, 360 degrees is seen as a complete revolution. And in terms of radian, that is 2 pi in radian. Okay. So once you have this basic relationship, then you can move on from there. So if you divide both sides by 2, for instance, it means you have 180 degrees to be equal to pi in radian. Okay. 180 degrees is pi in radian. So if you move ahead and divide both sides by 2, right, 90 degrees is the same thing as pi over 2 in radian. If you move ahead and divide 90 by 2 again, it means that 45 degrees is the same thing as pi over 2 divided by 2, which is pi over 4 in radian, and so on and so forth. So we have other parts, like you can divide these by you can divide 180 degrees by 3, and you get 60 degrees. So it means that 60 degrees is pi over 3 in radian. Of course, you can also divide 180 degrees by, say, you can divide by 6. If you divide by 6, right, you have 180 degrees divided by 6, that is 30 degrees. So it means that 30 degrees is pi over 6 in radian, right? Pi over 6 in radian. So you can keep playing around with this, because this becomes very useful, as we are going to see as we go on subsequently. So for instance, now you should be able to convert from degrees to radian, depending on whatever you're given. For instance, if I say convert 270 degrees 270 degrees to radian, what do? So to convert 270 degrees to radians, you simply establish the fact that 180 in degrees is the same thing as pi in radian. So now if you have 270 degrees, let's assume that is x in radian. So you have to cross multiply and get the value of x. So in that case, now it means you have 180 degrees times x is equal to pi in radians times Okay, let me put the whole thing. 180 degrees times x in radian is equal to 270 degrees times pi in radian, right? And what we need is x. So of course the radian can cancel out. Let all the degrees go. So so it means we have 180x equals 270 pi. Okay. So that means that x now, x that is in radian is equal to 270 pi all over 180. So we can go ahead and then say x is equal to 0 over 0. 0 cancels 0, right? And then what else can go? 9 goes here twice. 9 goes here 3 times. So you have 3 pi over 2. So you can say, therefore, 270 degrees is the same thing as 3 pi over 2 in radian. So you should understand this kind of conversion. It's very useful, for our knowledge of trigonometry, right? What if I say convert? What if I say convert 7 pi over 6 radian to degrees? So what if you are required to do that? So again, establish the fundamental that 180 degree is equal to pi in radian, okay? And then it means that 7 over 6 pi, 7 pi over 6 in radian is simply going to be like x degrees. So you have to cross multiply, right? So if you cross multiply, you have pi x is equal to 180. Of course, all the degree and radian will cancel out. So we have over time equals 180 times 7 pi over 6. 7 pi over 6. So pi can cancel pi here already. So you have x to be 6 here is 1. 6 in 180 is 30. 30 times 7 is 210 degrees. So you can see that, therefore, 7 pi over 6 in radian is equal to 210 degrees. So you should be able to convert from degree to radian like that, and radian to degree. It's very useful, as we are going to see very, very soon. Okay, so that is about circular measures. That's all I want to say about circular measures. So let's move on to trigonometric ratios. Let's move on to trigonometric, to Pythagoras theorem. Yeah, I mean Pythagoras theorem. So Pythagoras theorem. So the idea of Pythagoras theorem is very straightforward. It looks very simple, but it has profound implications in trigonometry, the Pythagoras theorem. So Pythagoras theorem relates with a right-angled triangle. Of course, you already know a right-angled triangle is a triangle that contains a right angle, which is 90 degrees, and this is it. So usually in a right angle triangle, just the biggest angle in every right angle triangle is the angle 90 degrees. And the side facing it is always known as a hypotenuse, whereas the other two sides can be said to be adjacent sides. But then when you know a particular angle, so for that particular angle, then the side facing it can be said to be the opposite, while the other side can be said to be the adjacent. But if this is the angle, the opposite of this angle will be the adjacent of the first angle. Like if it is this angle you have, then this will automatically be the, okay, let me even do this for the sake of clarity. So if the angle you have is alpha, so for that alpha, let me use something bright to really take care of the difference. So if the angle you have is alpha, the opposite of alpha is going to be this one. This is the side facing alpha. And then for alpha now, this will be the adjacent. So the adjacent and opposite are not fixed. It depends on the angle you're looking at. But the hypotenuse is always fixed because it is always facing the longest side, which is the right angle. So having understood that, right, Pythagoras came and told us this very profound idea that for every right angle triangle, if you have side A, side B as the adjacent sides, and the hypotenuse is C, that the sum of the squares, of the adjacent sides is equal to the square of the hypotenuse, meaning that okay, let's say now okay, let's just fix this to be theta, right? And we say this is, or let's say, I mean, you can fix it to be anything. Let's say this is alpha. So it means for alpha now, this is opposite, and this is adjacent, and this is hypotenuse, based on alpha now. So Pythagoras simply tells us that the square of the opposite plus the square of the adjacent is equal to the square of the hypotenuse. That's simply what Pythagoras tells us. That means that opposite, which is a squared, plus adjacent, which is b squared, is equal to square of the hypotenuse. So this is a very basic law, that we need to pay attention to. So that simply means that if you have a right angle triangle, say, the right angle triangle can be anywhere as far as you have this 90 degrees. So if you have this side now, so you can always get anything. So let's say if you can say this is 2 and this is 7, for instance, and let's say this is x. So you can always get the x based on a Pythagoras theorem, because you always know that x squared plus 2 squared is equal to 7 squared, meaning that you have x squared plus 4 equals 49. That means x squared is equal to 49 minus 4, which is 45, right? So that means that x alone is square root of 45. So in this case, we take just the positive because we are dealing with lines, right? So there's no negative line. So we have x to be equal to square root of 45, of course, this is square root of 9 times 5. So that simply means that side is going to be 3 root 5 units, if you like, 3 root 5 units. So that's the idea of Pythagoras theorem. That's another foundation that we really need to pay attention to. It's another foundation we need to pay attention to. So lastly, we talk about trigonometric ratios, which is also very important. So let's talk about trigonometric ratios. Trigonometric ratios. Okay. So here, talking about trigonometric ratios, still related to a right angle triangle. Just like I told you, the most important type of triangle, talking about trigonometry, is a right angled triangle. So if we behave like before, and we have alpha, and this is A, B, C. Now we have, and again, based on the alpha now, we can say this side is the opposite. This side is the adjacent. Or some people call that adjacent, I mean, depending on your accent. And C is the depending on how you like to pronounce it, actually. So this is the hypotenuse. Now we have 6 trigonometric ratios. 6 trigonometric ratios. Erroneously, some people believe it is just 3, but we actually have 6. So, and what are those 6 trigonometric ratios? First of all, we have the ratio of the opposite to the hypotenuse. And that is, so we have the ratio of the opposite to the hypotenuse, which is the same thing as what is called the sine, that is the sine, and it is SIN for short. Okay. Then we have the ratio of the adjacent over hypotenuse, and the ratio is called a cosine. It's called a cosine, or cos for short. And then we have the ratio of the opposite to the adjacent. That is simply called the tangent. That's called the tangent, and that is tan for short. So now the other side of the story is that for each of these ratios, we also have the reciprocals. We have the reciprocals of these things. So imagine that you have hypotenuse over opposite. That is simply the reciprocal of sine, and that is what is called the cosecant. Cosecant, and for short, we can call that CSC. CSC for short, cosecant. Again, we can have the hypotenuse over adjacent, and that is, so the hypotenuse over adjacent is the reciprocal of cosine. And the reciprocal of cosine is simply what you know as the secant. It's the secant, right? Secant. and that is sec for short. Sec for short. And lastly, you have adjacent over opposite, and that is the reciprocal of tangent, and that is simply called cotangent, cotangent, or cot for short. So these are the 6 we have. You have sine, cos, tan, and their reciprocals, cosecant, secant, and cotangent. Very important. So final in all, we simply can say that sine alpha, okay, we can say that sine alpha is opposite of alpha, that's A, over the hypotenuse, which is C, right? That's sine alpha. Then we can say cos alpha is adjacent, the adjacent B over hypotenuse C. And then we can have tan alpha. Tan alpha is opposite. That's the opposite A over adjacent B. And then we can also have cosec alpha. Okay, sine, the reciprocal of sine is cosec, right? Cosec alpha is C over A. Then we have sec alpha. Sec alpha is C over B. And we also have cot alpha. Cot alpha is B over A. Now, there's something very interesting about all these relationships. Check this now. Look at sine. Let's see sine alpha over cos alpha. Let's see what happens. Sine alpha we know is A over C. Cos alpha we know is B over C. That means we have A over C divided by B over C. That is A over C times C over B. So C cancels C, and we have A over B. And what is A over B? You can see A over B is tan alpha. So that is we are already establishing something there, that sine over cos is equal to tan. That's extremely important to know. Sine over cos is equal to tan. Now, apart from that, of course, you can extend this to mean that since tan is the reciprocal, of cotangent, right? So we can say that cot alpha, right, is equal to 1 over tan alpha, okay? 1 over tan alpha. And that is 1 over tan alpha itself is A over B, okay? And that is simply, okay, well, that's not the thing I wanted to do. So tan alpha, we already know that tan alpha is sine alpha over cos alpha. So that means we have cos alpha all over sine alpha. So again, we see another relationship that cos over sine is equal to cot, okay? Being the reciprocal of tan alpha. So those are very important thing. That anytime you have sine of something over cos of that thing, it gives you the tan of the thing. And anytime you have cos of something over sine of that thing, it gives you the cot of the thing. So these are very important relationships that will be very useful for us as we move on in our study of trigonometry. So on this note, we have laid some foundations for trigonometry. See you in the next video, where I talk about another very important concept before we begin to delve fully into the whole idea of triangles, of trigonometry. So if you have not subscribed to this channel, be sure to do that so that you can always get videos. You can interact with all the videos here. Then, of course, you want to hit the notification bell so whenever I release a new video, you get alerted. Then please always like, share, and comment. There are a lot of people that need this. This will really help them. So we want to make them have access to it, so we can all learn together. So comment if you have questions on whatever area of mathematics. We may be able to help out on that. So see you in the next video.